Hello everyone, welcome back to my channel. It's been a long time since I posted. Today I'm back with pulse current response of RC and RL circuits. So these circuits are complex if you want to analyze the transient response of these circuits, but then if you only want the steady state response, that is pretty simple to analyze. So today I'll be telling you a method by which you can directly write the steady state responses for pulse current input or pulse voltage input for any kind of RC or RL circuit. So I'll tell you a method which will help you to directly write the pulse response. Okay. So let's say we have a pulse current source that goes from I to 0 with a period of t. Okay. And you have a RC circuit. So there are two cases in such problems where you compare the time period of the clock with the time constant of the RC. So when the time constant of the RC circuit is very small as compared to the clock period, those cases are pretty simple and trivial to analyze. So in both these cases, I'll be assuming that the time constant is much higher than the clock period, such that they don't charge and discharge completely, and then it is a little bit trickier to analyze. So we'll be dealing the cases in these cases. I'll be assuming that tau is pretty much greater than the clock period, so that they don't charge and discharge completely. Okay. So in the first case, so the basic thing that I wanted to stress on is there is a pulse input from I to 0 and there is this RC parallel network. Okay. So we'll be plotting the voltage and the current through the capacitor and the voltage at this node in steady state. So what will happen in the steady state is there is something that I would like you to keep in mind. In steady state, the voltage across the capacitor will ripple around its average value and the current through the inductor will ripple around its average value. Okay, this is the most important point, and if you know this, you can pretty much analyze any kind of circuit. So this is the most important point. So what do I mean by average voltages? I mean the average voltage when this current step is applied. So what is the average value of this current step? It's I by 2, right? So this is I by 2, and in the steady state, this gap will be an open circuit, right? So this will not be there. Whole I by 2 average current, I repeat, average current will flow through the resistor, and it will give you a voltage drop of IR by 2 across the cap. So now, since the voltage across the cap is in steady state is the value that ripples. Okay, so the voltage at this node is the voltage across the cap, and the voltage across the cap will ripple around at its average value, around its average value in the steady state. So then this will not change in steady state. It will ripple around this value. Okay, by the line I mentioned. So this is IR by 2. So since the average value of this is I by 2, this is an open circuit. All the average I by 2 flows through this resistor, creating an average voltage drop of IR by 2. Now this voltage drop will remain constant. Why? Because the voltage across the capacitor, I already told you, it ripples around its value. So this is IR by 2. So this will ripple around IR by 2. Okay. So this is the voltage waveform at this node in steady state due to the pulse input for tau greater t. Now what about the current? So see, once you know the voltage, right, finding the current is very trivial because you know the voltage at this node, which is IR by 2. So this current is always I by 2 because this is IR by 2 by this resistor R. So this current is always I by 2 and this switches between 0 and I. So when this is, since this is always I by 2, when this is I, this is also I by 2. And when this is 0, this is minus I by 2. So it will toggle between I by 2 and minus I by 2 when this is toggling between I and 0. Simply because this current is constant to be I by 2. Because this voltage will not change. It is repelling around its value, as already mentioned. Okay, so this is something that will help you analyze. Same concept you can apply in inductors, RL circuits also, or any kind of circuit for that matter. So for an inductor, what will the case? The current through the inductor will ripple around its average value in steady state. So if the current through the inductor in steady state is I, which is the average value, it will ripple around its average value. Okay. So here also we have the same current pulse input and we have a RL circuit and we wish to analyze the voltage and current through the RL circuit. So first of all, what is the average value of this current waveform? It is again I by 2. In steady state, inductor is a short offering lower impedance as compared to this resistor. So all this average current will flow through the inductor. So this inductor will have an average current of I by 2 simply because it offers lower impedance. So all the I by 2 average current will flow through the inductor. So this is having average current of I by 2. Now this will not change. So the current through this branch will ripple around its average value. Since it is the current through an inductor, it will ripple around its average value and it is I by 2. So the current will simply ripple around I by 2. Okay, now if you want to plot the voltage waveform, since this current toggles between I and 0, this is fixed at I by 2. This will toggle between I by 2 and minus I by 2, because this toggles between I and 0 and this is I by 2. So when this is I, since this is I by 2, this will I by 2, this will be I by 2. When this is 0, since this is I by 2, this will be minus I by 2 to satisfy KCL at this point. This current will not change because this is a current through an inductor, and current through an inductor ripples around its average value in steady state. Okay, so this is I by 2, this toggles between I and 0, this toggles between I and minus I by 2 simply to satisfy KCL at this point. Okay, so since the current through the resistor is toggling between I by 2 and minus I by 2, the voltage will be toggling between I by 2 and minus I. So using this concept, you can analyze pretty much any kind of complex RC circuit with pulse current input or pulse voltage input. Just keep in mind those two things, and the logic behind the two things is simple. The voltage across an inductor does not, the current across an inductor does not change in steady state, and the voltage across the capacitor doesn't change in steady state. So it will ripple around that. Simple. So this will help you analyze, and yeah, I thought that this would be a good thing to share with you guys. If you know this, then all these circuits seem trivial in steady state at least, and you can draw the waveforms very quickly. And you can solve these questions in frequency domain also, but I would advise to solve these questions in the time domain, because if you know this thing, you can pretty much draw the waveform in the steady state at of any RL or RC circuit with pulse current or voltage input. Okay. So felt good to be back on this channel after a long time, and I was hoping to post a video about my gate experience sometime later. So about a week later, I think I'll post that video. So stay tuned, and thank you for watching. I hope this helped you, this idea helped you, and I hope I was able to deliver to you in a good manner. So yeah, thank you for watching. Stay tuned, like, subscribe, share. Thank you.